Hi, so I filmed a bunch of stuff about this conveyor belting, um, and it went way too long. Right now this is what I have anyway, that I was working on. As you can see, I'm getting instance counts of whatever is overlapping so that I can manipulate the instances on its own, but let's not get ahead of ourselves. I probably won't even get there. I just want to show you the different ways that you can lessen the load on the computer running this. So right now there's I'm not gonna even touch those. There's 4 instances, and the instance that I'm using here is not spinning, is this blueprint over here. So I have this blueprint over here which is spinning, and this one is optimized to have many instances of the same. So let's go back and use the original one first. Okay, so we have, I'm going to set the Z to 0 here just so that they're on a different level. So we have those conveyor belts. Those are 2-meter blocks, and you can see that the cylinders are spinning, but they're not. If I go and show the collision mode, visibility collision, well, visibility collision, yeah, is going to do that. A player collision, however, they don't even have collision to be able to rotate with. So, you know, the only reason that they're showing is probably because the metal that they are set to or whatever. But they have no collision themselves. So they automatically overlap. So we have a bunch of those. So 1, 2, 3, 4, and 5. Okay. So each 5 of those has 10 instances of rollers, by the way. So if we multiply those instances down, let's say we make 1, we make 2, we make 3, which is actually 4, and we make 5. Okay, and then we go back and select all of them and split again. So we have now 100 rollers, right? Something like that. Keep reselecting it, and I'm at 80 FPS right now. So I'm going to flip another 100 here, and let's make it like that. So that will be 112 actors right now. I'm going to dupe one more time so that we get an insane amount of actors, and the FPS now is down to 33. So it's not that good, but let's double check, make sure, yeah, static lights are gone. Okay, so how do we make that better? Well, we make that better with the mini version. So the mini version uses instancing. Instead of having each of those as separate instances, we can leverage the fact that we can have rows. So let's do a row of 10 maybe, with a spacing of 50 maybe, probably tighter. 40, 20. Okay, let's see that the spacing is right, and let's go for a row of 50, which is a lot more. Okay, and then we want to get the same amount of rollers. So the rollers was 100, we said. There it is. Notice that the FPS hasn't dropped below 33 FPS when I did all of this. Let me just set the scale for this to something like 5, and obviously 5's not enough. Maybe a scale of 6, to scale of 10, scale 10, and 120 rollers, 110 rollers there. Okay, So yeah, the mesh down here is scaling, which is not ideal, but you know, you can change that. So now we have a much larger surface at almost no cost, and we can get rid of all the other instances which are eating up our memory and rendering. And by the way, I have 2 or 3 blueprints open, so performance is affected by all the windows that you have open as well. But I'm back to 90 FPS, and then if I close those, it'll shoot 120, 115. Okay, so that's how this works. This is instancing. This is what the instances does. Now, as far as the material itself, you can see all the rollers rolling, and well, that's the stopped instance, so no, that one doesn't apply. But this one here, I can make them go really fast, and you can not see them anymore, or I can just stop them. And let's set them back to 0.25. And let's say I want this particular instance to go the other way around, right? Well, I can't do that per instance without touching the code again, but it is set to here where I can just change the direction. So -1 goes one way and 1 goes the other way. Now, depending on what you're making with this, obviously you're never going to have this many in a scene. Probably going to have just a belt like this made out of a few components, and so the rest of the functions that are available, and you can actually just use the many one instead of the single one. It just gives you the possibility to expand, say, you know, if you wanted more rows or whatever, more rollers, if you want to stretch it out. So what was I saying before that? Right. So what we can do is change this mesh, and it's all dynamic. So if I set the mesh here, the size is adjusted, and I can just change the instance count to 5 and change the offset to like 8, because the mesh is not aligned properly, really. And I have a little end cap that I can use, and then I have the exact same instance, right? And I need a small little piece. Maybe it would be a curve, maybe it would be something like that. And I can adjust the position of that again to 0 to 5, and I have another piece that I can patch in, and then for the middle piece, because I don't want to reconfigure, I'm just going to double one of those. Okay. Okay. And then I have the piece here. And now the important one, and why the rotation mattered, is that when I rotate this piece, if I go and look at it now, it's visually opposite to, well, this one is one that's stopped, huh? So what we can do is put one of those in here, and then right click this, replace with many. What? Replace with many. There. Alright, so as I was saying, at some point you'll see that the rotated one needs a flip of direction. There you go. Now it's flipping and going the right way. So from start to end. And those are all rotating at once. So that's one thing. This is another. I'm not sure when I'll finish that. But now I'll walk you through the blueprint and how it's actually working. So you saw the variables, you saw what it does. Let's start with the basic one. So in the viewport, we have a default scene root, a static mesh, and a hierarchical instance static mesh component. Okay. Those are all just, you add component and you add it in here. Hierarchical instance is a little better for what we're doing, so do use that. And then I have variables here. I add and create variables that are going to populate the construction script. Now if I unplug the construction script and compile, the instances are gone. And while we're on that, if I select this and I want to manually add instances, you can. You don't have to do this via code. It's just a heck of a lot easier to do via code. Where are they? Instances right there. Click plus and you can see one adding. You can select it and move it, and you can add another one, and you can select it and move it, etc., etc. You can do it manually. Good luck with that. Or you can just delete all of them and hook up the construction script, which we'll go over. Okay, compile, go back to the viewport. You can see it just spawns and adjusts. All right, save. Let's go over it. So first thing that we have here is a bit of math for the mesh size. What that really is just getting the inverse of the maximum value of the box multiplied by the scale, which by default is 1, setting it up with a little manual offset, that is the offset that you saw me changing earlier, and memorizing that as a mesh size variable. From this variable, we'll deal with that later, but we subtract the instances so that each instance is at a different place. We're setting the base mesh, by the way, to the mesh that I exposed here. So I just added a variable called a static, or picked static mesh, and I'm manually setting that with the exposed so that it's replaced at runtime or on construction. And then we have clear instances. We get rid of everything. Every time we build, we do the instances from scratch. We have the war scale of the instances set to 1, because if I bypass that node and I don't activate that node, this is what happens. When you go into here and you scale up, then you get instances like that, and that's not a good idea. So we set their scale to 1, and this is world scale 3D. Make sure that. Then we get the materials. The option, the name here is optional, doesn't matter, but the one here is not. This is the set of the material parameter, and it's based on just the float that we input in and expose, so that it's exposed. We set this material for the element 0 in my case. You might have a different element, but each roller is a separate thing, obviously, so it's a separate mesh. In fact, here's the mesh in the other window. We'll go to it in a second. So to finish this, we have an instance count, and for each number in the loop, it will just go over adding an instance. Like I said before, we take the mesh size, and because it's a negative number, we start adding. 18 is just my arbitrary number based on the size of the actual mesh here. I could do it based on the extent of it so that it would be dynamic, but that was overkill. So, you know, this number, this loop gets 0 is adding 0, 1 is adding 18, 2 is adding 18 times 2, etc. All to the transform. So that should work well for you as a base. Let's close that out. Let's also close that out. And so the mesh, this is the mesh. You can see it's set on the y-axis, so that's how it's rotating over there. Okay, close that out. Let's have a look at the mini version, which is the one optimized to be able to loop the rows. So what's different? Well, instead of having a base mesh, we are using a static mesh base component here, and the node here is actually exactly the same. Let me zoom in more. But this one is, you just drag in the new one and replace it. go with the hierarchical one, and we're adding an instance at 0, 0, 0. This is the first instance, and we're always adding this instance. After that's done, the rest is pretty much the same until you get to the rows. Excuse me. So you have a number of rows and a number of instances of the pins. The number of rows is going to control how many instances you spawn, and for each instance that you spawn, we need to adjust and set up a row number to use, basically. So we have a F row offset, which is the distance between the rows, basically, and to which we're adding a meter, and that's arbitrary. We could just bypass it. But I figure because the mesh I created is about 1 meter wide, then this becomes like each mesh can be distanced by a specific amount. And if I set this to 0, they'll be touching or nearly there. So like the other one, we multiply the index by this amount so that each row is in a different place. And then we memorize it as a different variable. So we have a F row offset and an F stands for float, row used offset. The used offset is the one that we actually used when populating the instances, because that will need to update the Y position in my case. It's based on how you generated the mesh. We don't actually need to pass a scale in there. It's automatically set by default because it was working. Excuse me. So because the instance initial scale is set to world here, then any instance you add will keep that in mind. The rest of the process is the same, except for we're using the offset of the row inside the location Y, and that generates the incredibly performant billion sets of rows. And we can quite literally, actually, I didn't do it this video. I hate that bug. I didn't do it this video, but yeah, so with this one we can set the scale to like 5 or 10. Let's do 10. Let's set the instances to 100, and then let's change that to like 9. So there, it's a bit extra, okay? We can do for 9.15 maybe there, just for visual. Okay, so that's 1,000 instances. Let's say we double that, make that 1,000 instances, and then so 9.15 would be times 10. Okay, so this is how many instances we have right now. There's a margin of error on that. 90 is probably enough. 90.001. 90.005. 90.01. Ooh, look at that. 90.05 is too much, right? Yeah. 02 is too much still. 15. Anyway, you get the point. So that's 1,000 instances we said, right? And then for the rows, 1,000 rows. Now we wait because it takes a while for it to go through 1,000 by 1,000 loops. And here it is. And let's say, so it's at a distance of 1 meter each. I don't like that. Let's make it tighter. 0. Again, I'll take a bit because it's a lot of instances to go over. Here it goes. All right. And my FPS with 1,000 by 1,000 is still at 42, and I have a blueprint open, so if I close this and I click away from the instance, I'm at 40 something. So do you think you'll need this many rollers? Anybody? Can make a really funny game where the character just walks on the rollers and keeps on falling all the time. Awesome. Okay, so what was I saying here? Performance aside. And when you have the meshes like that, it's kind of important that you don't try to access the hierarchical mesh like this. When you have a lot of them, you will literally brick your computer if you try and modify the instances. It'll just lag you to death if it even manages to load. Okay, so that's done. Let's go over the material. So the base material is just metal, and I have it set to be pretty dark, and so it doesn't really matter. The one that rotates is the one we need to look at, and here it is. Okay, so let's start from here and work back. Okay, we have an albedo. We have it set to texture 0. We have it set to metallic. We have 0 roughness, so that it's really shiny. And now we have the normals, and we have a world position offset. The normal map right here needs to be corrected. This is what happens when you don't have the normal map corrected. So you know, you're aware of the limitations. Also, that flickering that you saw as the rotation was happening is actually part of the issue. And you really can't get that to go away, but so this is what happens without that. This is fine if you are making a well, actually it's not fine, because if you go into lighting detail, you'll see that basically the bottom is shading as if it was unlit. I don't really know why it's doing that. It's like it should just be live right away, but passing in the normals here, the corrected normals will adjust that, so who cares. The reason for the vertex interpolator here is basically optimization. I can do this, and I can also obviously need to set this to have the customized UV output. I wonder if this should be like that to bypass the UV before it's optimized, or if it's going to cause issues in loop or whatever. It's not erroring out though, so I don't know. Okay, so that's basically the same thing. It's just that it's taking the calculation to the GPU from here and then combining it back again. If you read the description, it tells you to do that basically. Using the vertex interpolator should be doing the same thing under the hood, so I can avoid having to deal with the custom and then possibly overriding that UV0, which is painful. Because when you're trying to do stuff that's a little more complex, it gets problematic. Okay, so why are you not running there? Well, but you're running there, so whatever. Okay, so we have the rotate about axis node. Let's talk about that one first. So the movement is happening based on a normalized rotation axis. The rotation axis in this case is Y, the Y axis, but it's transformed into world space so that you can rotate the item any way you want. And then it's normalized because it's normalized. I have no better explanation. It's just a 0 to 1 range. Then we have the rotation angle that's given by a time. I have the direction multiplied by time dilation, so you can speed up or slow down, as well as flip which direction you head. And that's multiplied by a time node and fed into the rotation angle. Now the rotation angle is just usually at 0 to 1 value, so time overlaps or loops around that. Anytime that the value is greater than 1, you're basically starting a new rotation. So keep that in mind. Then after that we have the pivot point. In this case, the pivot point, because the way it built the mesh, is just literally 0, 0, 0, transform position local to world. You can just use the object pivot. It's the exact same thing. In fact, if you open it up, you'll see that it's the exact same thing. I usually just do different things, so I start from this and modify the 0, 0, 0 probably to get a different position if I don't want to mess with the model. And then we have the absolute world position, which is passed in here, and that's perfectly just how it needs to be. The fixed rotate about axis normals is a material function that you can just call in. It's available to the engine, and it fixes that issue with the normals that we saw earlier. So if I apply this, and I'm not sure why this isn't rolling anymore, but if we go here and we look at it now, the normals, aside from the flickering that happens at a distance and every once in a while, are mostly okay. So the light is staying below, and everything seems to be working more or less fine like it was before. That's basically it. I'm actually working on getting this one to collide, as you saw earlier, and that's a bit of a chore. But most of the code is running on the box itself right now, so I'll show you that, and you can maybe start working on your own version of it. Go to the cube, bring up the box. So we have a box here. This is the code for it, right? The important part is that the box has a box. So if I delete or hide the mesh here, you can see that the box has a box. The static mesh is actually set to no collision, and the box is set to a custom collision channel, in which I am setting everything to block in this case, but it's set as the object type is set to physics body. And then if we go look at the conveyor belt stopped, bring it up over here, and there it is, moving right there. We can see that the collision box on the static mesh component, by the way, because you know that's the one that we want to overlap, is set to overlap physics body. Okay, so we're overlapping everything, but the other one stops it so it doesn't fall through. That can be, you know, useful for a number of things when playing with collision channels. Again with that. Okay, so before we go through that, let's have a look at this mesh, because I think I said it has no collision, but it probably does. It's like auto-generated. There it is. So this is being used inside the hierarchical mesh component. Wait a second. Did I change anything? I didn't change anything. No, we don't want to save anything. Okay, so let's open up the box itself again and quickly have a look. So each time that there is a begin overlap event with the box itself, we are saving out an actor, and on event tick, if that actor is nothing, so it's actually been set, we had a collision, we start working. So what we're doing here, we are looking at, we're checking to see if this object that we overlapped with is actually the conveyor belt stopped, which is the variation that doesn't automatically move. And then out of that, after the cast, we are picking all of the component. This is the hierarchical instance static mesh component that I added to the mesh, and we get the overlapping actors, and we check against ourselves to make sure that it's us. And if it is us, we get the overlapped components, which is always component 0, the hierarchical. We're getting the, basically we're getting the static mesh again, right? This might be a bit unnecessary since we have this one here and we already know that we're looping. So let's try and get that better, right? Let's see if we can just omit this portion of code. Feed right into there. Compile, save. Right, we need a target for the instance, and the target for the instance is right here. Okay. Going through with the rest of the code, whether it works or not, if you know, can always revert back to the other rotation. So we're getting the location of self of the actor location of self. We're getting the size of the box, scaled extent, and we're creating the box min, box max values to do an instance check with. And we're from this one, you drag and you type get instances overlapping box. You feed the box the values, and with that you have an array of results. We can actually get rid of that display name over there, and I can actually get rid of the drawing box over there, but it's useful to know if you need to draw a debug box, you can do that. Very simple. Just takes the center and the extent and it does it on its own. Since it's already on screen, it's kind of pointless to redraw it, but it was helpful for debugging the size because of the scale that the box can have. And then if I play this, I should be getting the list. Yep, so it's still working as expected. And you can move it, and the actor swaps and changes, and you get different indexes. Now the idea is that I can toggle the movement or the speed based on an index, and then maybe make it scale back down. So right now it's not giving me any responses. I wonder why it stopped, but there it is. Now it's set and it's rotating again, keeps on going. So need to work on the rest of this, but yeah, that's it. Hope that helps. Good luck.